this lab, we'll be exploring solubility. The guiding principle to remember is like dissolves like. The idea is that polar compounds dissolve in polar solvents, like water, and nonpolar compounds dissolve in nonpolar solvents, like, say, diethyl ether. This idea of like dissolves like is what makes this comic by Tyler Larson so funny to some people. Hilarious, I know, but the idea is there. What we're going to do in this lab is separate two compounds by adjusting their polarity, thereby adjusting their solubility. Tear the mass of your whey paper and then weigh 50 milligrams of your 9-fluoronone and your ethyl 4-aminobenzoate. Add your two compounds to your centrifuge tube.
So in your centrifuge tube, we now have ethyl 4-aminobenzoate and 9-fluoronone. You're going to add your 4 milliliters of diethyl ether. And before you put it in your ice bath, you want to make sure that these solids at the bottom dissolve, and you can do this by shaking and then vent. Looks like they're dissolved, so and then you do that, make sure you do that before you place it into your ice bath.
Add about 2 milliliters of 3 molar HCl dropwise to the centrifuge tube while swirling. 2 milliliters of HCl is about 2/3 of an inch of solution. This will protonate our ethyl 4-aminobenzoate so it can make hydrogen bonds and dissolve into the aqueous layer. Once you've added your acid, invert with venting. Remove the bottom aqueous layer and place in a 10 milliliter Erlenmeyer flask.
Be sure to push out all of the air in the pipette bowl before inserting it into the centrifuge tube when you collect the bottom layer.
We'll get the 9-fluoronone out of the ether layer still in the tube later, so make sure you put it somewhere safe.
Now you will add your 6 molar NaOH to your solution until it is basic. This will deprotonate the protonated ethyl 4-aminobenzoate, causing it to be insoluble in water and precipitate to the bottom. Here you can see that ethyl 4-aminobenzoate is precipitating out of solution. To get all the product we can, we will add base until the pH is basic. Check the pH every 15 to 20 drops of base by using a glass stir rod and letting a drop touch the red litmus paper. Eventually, you'll see a blue dot indicating that your solution is now basic. Once the litmus paper turns blue, cool your solution for 10 to 15 minutes. Now we're going to set up a filtration apparatus to catch our ethyl 4-aminobenzoate solid. You'll need a Buchner funnel, a rubber adapter, a hose that will attach to the faucet, a piece of filter paper, and a filter flask. Start by turning on the water to create a vacuum.
So once your filtration flask is set up, you take your distilled water and you wet your filter paper. And to check for good suction, you can simply just place your hand over the top and press lightly, and if it's sucking, then that's probably good enough suction to where you can filter out. As you're adding your solid and your mixture to the filtration flask, you want to make sure that there's no pooling happening with your funnel and your filter paper, meaning you can have water pooling up here without any water leaving. and this is what it looks like.
Now add the aqueous solution to the filter. When all the water has been filtered, wash the filter paper with water. Allow your solid ethyl 4-aminobenzoate to dry for 3 to 4 minutes with the water running. Tare a watch glass by recording its mass. After drying, turn off the water, remove your funnel, and gently slide out the filter paper. Scrape as much of the ethyl 4-aminobenzoate as possible onto the tared watch glass. Weigh the watch glass and ethyl 4-aminobenzoate and calculate the percent recovery. We'll show you how to measure the melting point at the end of the video. To the organic layer left over in the centrifuge tube, we're going to add 2 portions of 1 milliliters of water. After washing, you'll remove the bottom aqueous layer for disposal. Now to our remaining organic layer, we'll add anhydrous sodium sulfate. Keep adding anhydrous sodium sulfate until there is no more clumping. Tare a 10 milliliter Erlenmeyer flask by recording its mass. With a boiling stone added, transfer your dry diethyl ether into your tared Erlenmeyer flask. Wash the sodium sulfate with 1 milliliter of diethyl ether, and then you'll remove that diethyl ether and add it to the Erlenmeyer flask. Now boil off the diethyl ether. Note that the heat does not have to be very high. The lab says you'll have a yellow liquid left over after boiling. The boiling doesn't take very long. You know you're done when there are very few bubbles showing up on the boiling stone and the bottom of the flask is pretty warm to the touch. Once it's done boiling, remove the flask from the hot plate and allow it to cool to room temperature. Here you can see that once the 9-fluoronone solution has gotten to room temperature, it becomes a solid. Weigh and record the mass of the 9-fluoronone and the Erlenmeyer flask.
Now that we have our 2 products, 9-fluoronone and ethyl 4-aminobenzoate, it's time to get their melting temperatures.
Now we need to put our solids inside of a capillary tube. This tube has a top and a bottom. There's an open side and a closed side. So we're going to turn it upside down, put the open side down, and we're going to smash a little bit of our product in there.
Here we have our ethyl 4-aminobenzoate, the solids up here at the top. And in order to get it down to the bottom so we can read it in the Digimelt, you can place it in this tube tapper right here. Any one of these 3 holes is fine. You press this button and the solid falls down to the bottom. So now to set up your Digimelt temperature parameters, we know that the melting point of ethyl 4-aminobenzoate is 88 to 90 degrees Celsius. And so you take your Digimelt, and we want a start temp that's about -10 lower than 88 degrees Celsius. And so you press start temp, go down to 78 degrees Celsius, and then we want it a little bit, we want it 10 degrees higher from 88 to 90, so you do your stop temp. You can put that down to 100, which is +10 from 90. And as this is going to be melting your solid, your ramp rate, you want to set that to 5 degrees Celsius per minute. And once you have all that set up, press the start-stop button. Okay, now that the Digimelt reads ready with this green light next to the word ready, we take our sample, and you can put it in any one of these 3 holes, it doesn't matter. And then press start, and notice it went to the word melt now, and it's going to melt at the ramp rate that we set it at, and closely watch through this lens to watch for your crystals melting.
This is the view when you're looking inside the Digimelt. How the look of the substance changes helps you determine when to record your melting temperature. You'll need to record a range starting from the moment the substance looks wet and starts to glisten to the point when the substance is completely melted.
So the reason why ethyl 4-aminobenzoate has a melting temperature range of 88 to 90 is because a pure sample melts in that range. Now your sample could have impurities, which is why we're running it through the Digimelt. So as your sample is melting, it may start to melt at a temperature lower than 88 degrees Celsius. And really all that means is there's impurities, which is most likely water is in your sample. And water interrupts the crystal lattice of your ethyl 4-aminobenzoate, or any solid that water can contaminate it, and lowers the melting point, because now it's not theoretically a perfect crystal that matches its actual melting point.
Sometimes it's hard to tell when wet is, but you know the substance has for sure begun to melt when you start to see some movement and collapse, shown here. This is what it looks like when the substance is completely melted.